Welcome to Monochemistry. In this lesson, we're going to learn a little bit about organic chemistry. In fact, this is the first lesson of the organic chemistry unit. So I guess we're going to start off by just thinking a little bit about what the word organic means. And probably the first thing that pops into your head, or at least I shouldn't speak for you, but it's certainly the first thing that pops into my head. When I think of organic, I think of food that's organic. And when I think of food that's organic, I know that the definition of organic food is food that has been grown without the use of chemicals and pesticides and fertilizers and all that kind of stuff. But in chemistry, the word organic bears no resemblance to organic food. It's very different. The word organic itself means of life, but in chemistry, surprisingly, it doesn't necessarily have to come from living things, although a good chunk of the chemicals that we will talk about do come from living things. So down here at the bottom of the screen, I have some molecules that would be considered organic. So this one here, which is CH4, it's methane, and this one here, which is acetic acid, which is the same, hydrogen acetate if you prefer, and this molecule here, which is vitamin B3. All of these molecules are considered organic. Can you see the common theme in these things? We'll talk about the definition a little bit later on. But suffice to say, organic chemistry is not the same as organic food. It's very important to note that the study of organic chemistry often centers around things that are either developed by or actually are fossil fuels. Okay, so here we have some oil. This is a very old picture of an oil drill. And here I drew a nice little picture of some coal. And here again, we have methane, which is CH4. Methane is also known as natural gas. And all of these things are, in fact, considered to be fossil fuels. Now, interesting to note, many of the fuels that we actually use come from this oil right here, which is called crude oil. And crude oil is a mixture of many different organic compounds. And what we do essentially with that oil is we separate those organic compounds into individual types of fuels. For instance, from this, we can separate the crude oil into things like kerosene, diesel, gasoline, propane. All of those things come from this. And, of course, natural gas is also usually found along. Now, fossil fuels, the reason I'm bringing this up, fossil fuels are a particular branch of organic chemistry. And fossil fuels generally deal with a special branch of organic chemistry, compounds called hydrocarbons. So at this point, let's talk about what the definition of an organic compound is. So an organic compound is a compound that has carbon as its base, and it has to be a molecule. It cannot be an ionic compound. So it has to be a covalent compound, and it has to have carbon as its base. Now, the other thing, though, is that organic compounds, not only do they have to have carbon, but they also have hydrogen. So they have to have both of those things. They can have other things, too. It doesn't have to just be carbon and hydrogen, but they have to have, for sure, carbon and hydrogen, and they have to be covalent and not ionic. Okay? Now, fossil fuels represent a special branch of organic compounds called hydrocarbons. And hydrocarbons are special because they only have carbon and hydrogen. Okay, so that's basically the intro to organic chemistry. Just don't think about organic food when you think about this, or growing things organically. It's not really what it is. When you think of organic chemistry, think of all the different things that are made up of carbon and hydrogen, and carbon, hydrogen, and other things. Organic chemistry, because it's of life, you can think of things like sugars, proteins, fats. All of those are organic molecules, proteins. All of those things are organic compounds. But it's interesting to note also that many of the compounds that we call organic in chemistry are actually made by humans. They're human-made things. For instance, every single type of plastic that we use is technically an organic compound. A lot of them are even hydrocarbons. How can that be? Well, believe it or not, and this comes back to the fossil fuels here, believe it or not, plastics are all derived, they all come from this crude oil that came out of this thing here. They're all derived from that. Every single type of plastic that we use is a bunch of carbons and hydrogens. Sometimes there's other stuff. And yes, while we may make them in a lab, they're still, by definition, because they have a backbone of carbon and hydrogen, organic compounds. Alright, so that in a nutshell is what organic chemistry is, not more particularly what an organic compound is. So I want you to try this, and we'll go over this in class. I want you to try identifying which of these things on this page are actually organic compounds. So based on the definition I talked about, and you can use your textbook too, which of these things would you say are organic compounds? So you can either put, I don't know, put a check mark next to the ones you think are organic, and put an X next to the ones that aren't, or you can write O for organic and N for not, or NO for not organic. Whatever you choose is fine. But make sure you write your answers down, and we'll go over these in class. And that in a nutshell is an organic compound.